Hi everyone, I'm Nick and welcome to another episode of C++ Crash Course. We're going to continue our look into some things in the standard library today, and we're going to look at strings. So back in C, when we had strings, a lot of times they were constant and we weren't able to change them in our programs. We could change them doing a couple like tricks, like if we had an array of characters, we could change the elements in the array, but if we had a C-style strings, such as a constant char pointer to some text, we couldn't change that because it's constant. And strings allow us a lot of nice little tricks and stuff, or it has a lot of built-in methods that are convenient for working with text. So let's go ahead and open up our example, this string.cpp. Oops, it's already open. So we'll go ahead and import. We'll go ahead and include string from the standard library here. And we'll declare just like any other data type. So this is string data type. So we'll have string1. Then we'll just assign it. Notice it's non-constant, so our declaration doesn't have to be followed by an initialization in the same line. We can do that down here if we want to. And we'll go ahead and print that out. Then we'll have another string that just says this is another string that will do declaration and initialization at the same time. So then one of the first neat little tricks we can do is we can actually swap them. So if we need to swap two pieces of text, we can do that with just a swap method. So now string 1 will have the text, this is another string, and string 2 will have our original text, this is an example string. So then after that, we'll just print those out. Then we can, unlike C or those constant C-style strings, we can actually edit the elements of this. And so we can do that either with this @ right here, or we can do our normal kind of indexing with brackets, but we'll just go ahead and show off this method. So we'll just use @. So then we'll just change all of string 1 to be A's, right? So for the entire size, now with strings, just like with vectors, we can call this size to get the size of the string. And then we'll go ahead and print that out. Now there is an important note that there's two things associated with this string. There is size and capacity. Now these two things aren't the same. The capacity is always going to be greater than or equal to the size of the string. And so the reason why this is because if we want to say add new elements to the string or append onto a string, this is just kind of an optimization. So if we already have a little bit of extra room, say allocated, it can be a lot faster when we want to say expand a string. So in this case, we'll see what it looks like when we have this big long string of A's that we've replaced up here. Then we'll go ahead and resize it. So resize is resizing the string, but the capacity we'll see is going to, it'll stay about the same. And then we'll go ahead and do this shrink to fit, and that will release some of that extra memory. So here we'll go ahead and print out this resize to 5, and so instead of having a big long string of A's, we'll have 5 A's. And then this shrink to fit will also decrease the capacity as well. So in this case, the capacity will likely, and I do not think it will not go all the way to the size of the string, but it will decrease from its original size. So let's go ahead and I think that's everything. Yeah. So let's go ahead and compile this. So we'll go ahead and run G++. Give it the input, or our output will be string. Our input will be string.cpp, no errors, and we'll run string. So here's our example string. Then we swap them. So string 1 now becomes this is another string, and string 2 is our first string. Then we replace all the characters of this first string with A's. We see that in this case the size and the capacity are the same. Then when we resize, we see to 5. Our size goes to 5. And then we have all A's still, but our capacity is still 23. Now this means that we still have 23 places in this string if we wanted to say add more characters. Now when we do shrink to fit, it doesn't change anything about what the size of our string is, but it changes the amount that it releases a little bit of memory out into the system. So we just kind of relinquish it. In this case, the capacity goes down to 15. Now just remember that this is something where it's not necessarily equal to the length of the string. So when we do that shrink to fit, it doesn't shrink it all the way back down to 5. It's still a little bit bigger to optimize some operations, but that's going to do it for strings for today. It's a very convenient thing with working with text. So as always, if we go to github.com/coffeebeforearch, we go to C++ Crash Course. Here we worked with strings today, right here. And here's the file we worked on. So feel free to download this, play around with it, and shoot me a message if you have any questions. Like I said, I'm Nick from Coffee Before Arch, and I hope you have a nice day.